Okay. All right, we'll just wait for some learners to join. Six people are waiting on that. Okay. So welcome to this live interaction session of the course on demystifying networking. I am one of the faculty of the course. Can it be heard? Can you check? Huh? Can you check whether you can hear what I'm saying? No, another. Not sure. Okay. 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 So we'll get started. Welcome to this live interaction session of this course on demystifying networking. I am Professor Sridhar Iyer, one of the faculty. The other faculty, Kavya, Alse, will be joining us shortly over a link. And with me are the two TAs of the course, Vishwas Bade and Nisum Masudin. So this is just to introduce ourselves, and we will go for some questions that people have asked for. And meanwhile, you can also type your questions in the chat window. Okay. So there is a question about explain a bit about VLANs working. Okay, so these are all very ancient concepts. So networking actually nowadays moves very fast, right? So every few years the entire technology changes, and so really not much you need to know about VLANs today. So except that many of the switches can automatically be configured to set up virtual LANs. Okay. Okay, just give us a moment while we try to join the other.
Not yet got request. Try joining, and we'll let you in.
Okay, there's a bit of delay while the other instructor is trying to join, so please bear with us. Meanwhile, you can type your questions on the chat. No?
Are you able to? Yeah. Just even on the mobile, we have to. We tried testing it. That Kaksha, that link I have sent you, you can do that.
discuss some of the new areas in networking domain. You can ask some questions. You can ask the question instead of giving the answer. Yes. We'll have an interaction. Yes. Yes. Okay, I think we waited long enough. Let us proceed with the interaction. And if the network helps us, then we can join later. Okay, so there is a comment on the chat saying discuss some of the new areas in networking domain. Okay, so as many of you know, the most of the new areas are in the 5G, what you would have heard as 5G space. Okay, and a lot of it. So if you look at the various layers in networking, you have the physical layer and the medium access layer and the network layer and the transport layer and so on. So much of the research now is happening in the all this 4G, 5G is all in the medium access layer. So physical layer and medium access layer, which is where the whole idea of getting more bandwidth and getting higher throughputs is being worked out. Okay, so for that you actually need a little more doubly background, electrical, electronics and communication background, and not so much of a CS background to be really able to contribute in that area. So in terms of routing or how to do transport and how to set up sessions, the it's fairly stable, so people have not really changed. There have been only incremental modifications to the various protocols over the years, and there have not been very major changes which have happened. So if you really want to work in the networking or wireless domain, I mean, you will have to brush up on your medium access control, modulation schemes and MIMO antennas and so on. Okay, so while we are waiting, we will also have the TAs ask some question. So do you want to, we can have a discussion where we simulate some question that you have been thinking about networking. We can discuss now. Okay, check. Hold on.
Yeah, we have not got any request till now. Yeah, we are clear, no? Yeah, letting. Yeah. Now you're in.
Okay. All right. So we've been able to successfully troubleshoot this issue, and the other instructor, Kavya, Alse, is also online. Kavya, can you hear me? Probably not.
Hello, did someone say anything? I missed the first part of if somebody was speaking. Can you hear me?
Okay. I think let's not spend too much time trying to figure out how we can all get connected. So instead of that, let me talk about one experiment which many of my students had done a few years ago, and we will just show a video of that experiment. So the idea here was that there was a rural area in Andhra Pradesh, which was being run by an NGO, and it had a very interesting, peculiar problem. In that, it was in the middle of surrounded by hills, and there were not too many cell phone towers. So what I did was, this was about 15 years ago. So what I did was, I took a bunch of my students, we went to that area, and we tried to use Wi-Fi to provide connectivity from the different homes to the single landline which was there. So let me try to share this video. And we have to share computer audio. Share this one, right? Oh. So I hope you can see the video. This is Timbuktu. One of my PhD colleagues and close friends, Dr. U. Subbaraju, is living here and is also running the school here. So the setting here for communication is as follows. Timbuktu is surrounded by all these hills, and you see that it is not possible for us to get cell phone coverage, cellular coverage in this area. Although there are towers which are not too far away, about 5 kilometers away. The other problem of getting connectivity here is that there is a railway track which just passes about 1 kilometer away towards the main road, and laying cables or crossing the track using overhead cables is also not possible. So what connectivity is currently present at Timbuktu is just one landline which was laid very long ago. The problem now we are attempting to solve is how to enable communication amongst all the places in Timbuktu using just that one landline. So while this can be done in many ways, for example, we could have a EPABX set up and distribute internal communication lines. We are attempting to solve it using, first of all, Wi-Fi. And the second aspect of it is that there is no AC power as such in this place. So all these places are powered by solar, and so we have only DC power here. So the setting is as follows. We have the main kitchen and the mess over here. We have some of the residences and the school in that direction, which is another important place where we want to have connectivity. We have some more residences in this direction, where again there is a need to have some kind of a communication. The landline actually terminates in this kitchen, and there is also one meeting room in that direction. So what we want to do is to take the landline, somehow connect it as voice over IP over Wi-Fi, and be able to reach the school so that when there is a call for somebody, they can just transfer it using the Wi-Fi line to the school. Now we can take a look at how far the school is. It is about 200 odd meters, and as you can see, there are all these trees which have been grown by people in Timbuktu. They were not there about 10 years ago. and there is all this hay racks and so on, so which give us a lot of real information about propagation in rural environments. It's been now 2 days since my students have been working on trying to get this Timbuktu connectivity solution up and running, and we are happy to report that we have been successful at it. So what we see here is the antenna which is mounted on top of this building. The reason why we have had to choose this building is that it is the only one in Timbuktu which has AC power, which is powered by the solar panels, and there is an inverter which gives AC power, and the access point requires AC power for running the wireless network. So what we did first was to place the access point and take a few laptops and go around the place and get signal strength measurements, ping round trip time measurements, and we tried to establish a voice call using 2 laptops using net meeting and SJ phone. Once that was done, we installed exchange asterisk on another laptop, and we tried to have these 3 laptops now communicate through the exchange, telephone exchange. Once that was also done, what we did was to install the client on the computer, which our friends at the computer were good enough to get it to us right in the nick of time, and we tried to make a call between computers and to the laptop. So this took us the better part of nearly 2 days, and the last part was to actually connect a physical telephone instrument for which we had a Linksys phone adapter, which also could then be plugged into the access point using the Ethernet cable. So the cables that you see there, one of them is the power going to the laptop antenna, the yellow one is the power, and the white one is the Ethernet, which is going from the physical telephone instrument and the phone adapter. So now we can have any of these devices dial any of the other devices. So we have a total of 3 laptops here, one of which is running the Exchange server. All 3 of these can behave as phones. We have 2 computers which can also be used as mobile phones in this area, and we have 1 physical telephone with the adapter. And any of these devices can now ring any of the other devices, with the longest Wi-Fi range being about maybe 50 to 100 meters for the computer, and about 200 or slightly more for the laptop. So some of the interesting things that we have learned by this experiment, one of them has been that if you have a haystack in the line of sight between your antenna and the device, then that is a very powerful attenuator, and behind the haystack you really don't get any signal, almost independent of how close you are to the antenna. There have been other such learnings about attenuation factor in real rural environments, and that we hope to put down as a later report. This is the team which has
done this Timbuktu connectivity solution. And let me just introduce you to them one by one. First, on the extreme end here is Janak, and he has been primarily responsible for troubleshooting the system at IIT itself, doing VoIP ping tests, etc., downloading many of the things. The next one is Srinath, who has been working with the computer, and he has been constantly in touch with the Picopeta folks to get the VoIP client. Then we have Ananda, who has been a lot of moral support and enjoying himself from Cambodia. Then we have Samir, who has been manning the central exchange, which is the asterisk server setting up and all that. Then we have Ranjit, who has been participating as part of another aspect of this project. So he has been running around here. We have Subbu, who is a resident of Timbuktu itself, who has been really instrumental in setting up the antenna and all that. Shravan, who has been going around taking measurements and real world testing. Then we have Moni, who has been training some of the Timbuktu folks in Java programming. And finally, at this end, we have Raghu, who has been trying to set up the telephone adapter, and he has been sort of working all through the time to get everything going and putting all that together. So this is the theme.
Okay, so we are back to the main. Okay, so what that video actually showed us was that many of the technologies that you would have seen in the video itself, they would have all they're all fairly obsolete now, because you would have seen that Nokia phone, which I think gave up sometime around 2007 or 2009 or something. And many of these problems also are no longer existent. Like today, it is a very straightforward thing to set up Wi-Fi repeaters and keep hopping from the place where there is a network and extend it using Wi-Fi to a place where you need a network. So back then in 2006, this was a interesting as well as challenging project to do. And the main goal was that the belief is that only when students work with the technology, using their hands and try to build something, that's when the maximum learning happens. So that was the idea behind doing this experiment. So while I wait for any questions to come on the chat, Kavya, can we try one more time to see whether you are able to speak?
Yeah, I'm trying to speak. Can you hear me? Hello? Am I audible?
So
Yes, I can hear you
we are
all.
not able to hear you. Can switch that on.
Yeah, speak. Can you hear me?
Yeah. Yeah, Kavya. So we are able to hear you on the network, not in the meeting, but that's okay. Go ahead and speak.
Oh, so that means all others can hear me, or is it just you three? Hello? Hello? Am I audible? Hello?
Everybody can hear you.
Okay, fine. I think there seemed to be a significant lag. I asked that question probably a minute ago. So,
Yes, yes, yes. Just type yes in the windows.
You are audible, ma'am.
yeah, I'm speaking. I wanted to make sure that there were some questions asked in the form sent earlier. Did we get a chance to answer them? I joined in late, so
Yeah, I'm speaking. Wanted to
spot.
So, Kavya, you can take the question about network security, no? Why firewalls are needed and what are other aspects of security. So you can also speak a little bit about, troubleshooting and fighter.
Okay, I think there was some network issue. I seem to be back now. I got disconnected when Sridhar sir was saying that I can take some questions.
तो reply करना wait करके.
The first question was a crib, I think in assignment 1, there was some one question was wrong. So I think that has been notified and it's been taken care of already. And then there is another question about VLANs working. Okay.
first question was
Okay, so I guess that was already answered. Network security. I think the most basic aspects, fundamental aspects of network security is uh, pretty well covered in our course in the form of the CIA triad, which means confidentiality, integrity, and availability. Let me give a brief of what those three means again. So confidentiality means when your data has to be kept secure, it has to be kept private, and unwanted users should not be able to access that data. That is when you need confidentiality. And uh, to make your data confident, there are multiple things that you have to do. For example, you can restrict the access to data. You can have various types of access control policies, and you can use encryption, multi-factor authentication, etc., to make sure that even while you're transferring data from one device to other or from one person to other person, the data is secure and it doesn't fall apart to man-in-the-middle kind of attacks. That is the first part of confidentiality, first of the triad. Then you have integrity, which means that once you store data, it remains the same. It is not tampered with. It is not altered by unwanted users. So it makes sure that your data is trustworthy. And a way to ensure that your data is it has integrity is to make sure that you keep track of all the changes done and by whomever it is done. So this is called as non-repudiation. So whenever any changes to the data is done, then there is a track remaining who did the change, and so that you can follow up, so that no unwanted tampering or changes are done. That's the part about integrity. Then the third part is availability, which is when a user who has access to the data needs the data and the data is readily available to that user. So that these three form the basic triad of network security, and there are various threats depending on threats, intentional and unintentional, all types, and depending on these three triads you can also have measures to ensure that your data is confidential, integral, and it is available to users when required. That's all I have to say about network security. Is there still a lag? Because it's hard for me to gauge the responses. I will go to the next question. If there are any more questions, please post them on the chat window about network security. The next question was about network troubleshooting. Yeah. So
never mind. We can speak slowly and wait a few seconds to take care of the lag. So the other suggestion was about speaking a little bit about troubleshooting.
yeah. So I want to reiterate the basic phases of troubleshooting again, because they are sort of the core part of troubleshooting. These four phases are problem space representation, hypothesis generation, hypothesis testing, and result interpretation. So in problem space representation, what one does is to get a fair idea of what the landscape looks like, what the networking landscape looks like. That means what devices are there, how are they connected to each other. And you saw that in the previous video, in the Timbuktu video, we saw that even though there was an antenna and there was another device that was trying to connect, but because of the presence of haystack, there was significant attenuation and the connectivity was hampered, right? So even with well-known devices, sometimes because of the environmental constraints and all, they might behave in a different way. So the goal of problem space representation is to understand if the devices in the network are behaving in the desired way or not. If not, then what devices are not behaving in a desired way. So while we are doing this deductive thinking, then we might come up with some plausible directions to go ahead. This might be the problem or that might be the problem. Those possible directions are called as hypothesis. And then you pick up one of those threads and then does a systematic inquiry if this is the problem. And again, going back to the Timbuktu example, we were trying to see if that haystack was the problem. And then we probably the students did some experiments around that haystack. Somebody moved the laptop near the haystack and saw did the signal strength drop or not, and what happens when the haystack is very near to the antenna as opposed to haystack is far away from antenna. So all such experimentations will give you more information about whether presence of haystack in between the antenna and the device, does that cause significant attenuation or not, right? So such careful inquiry around that direction, careful inquiry in the direction of the hypothesis will give us a closure to that direction. That is the result interpretation stage. So at the end of such careful investigation, you can say that, okay, haystack is the problem or haystack was not the problem. If you find that haystack was not problem, then you pick up some other hypothesis and then do the careful investigation again. So this is the basic structure of how troubleshooting is done. And once you become experienced in troubleshooting, you might be able to come up with pretty accurate hypothesis very soon. But as beginners, the most important aspect is to understand what the devices are there and how are they behaving. Are they behaving in a desired manner or not? So that is why it is very important to start with getting to know the networking landscape. This is all about basics of network troubleshooting. Again, if you have more questions, please post them on the chat and I'll try to answer them.
Okay, so there don't seem to be too many conceptual questions. So I see one question which says, in link state routing, routers exchange entire routing tables. So actually that's not true. In link state routing, routers are going to exchange the state of the link. That's why it is called link state routing, right? So, and you can just refer back to that part of the video there where it is explained, no, how all these link state packets spread through the network. For example, like OSPF, there is also the next question is also about OSPF. So how the link state packets are propagate through the network and how each router then constructs its own routing table using the shortest path algorithm. Okay, so there is some administrative question also about for the final exam, will it be MCQ each of 1 marks? So no, it's not going to be that. And but it will still be a fairly easy exam, so you don't have to worry about it. If you have gone through all the contents of the course, you don't have to worry about that. And see, the key idea about this course is to actually give you a flavor of networking, not so much to go into detail and make you a networking expert. So for that, you have to take a more detailed course, which is the second level course. This is actually a primer, just for if you have no exposure to networking, and this is a fun way to learn about networking. So that is the whole idea about this course. And in the exam also, we will have questions which will be kind of similar. There will be some scenario where you will have to figure out what is happening, as well as there will also be questions of the type that you have worked with packet tracer and so on. Okay. So I see one more new question which says that, is there any easier method to do subnetting? Easier than what? So the typical method to do subnetting is where we are using subnet masks, right? So today, most of the routers actually use a technique called classless interdomain routing. Okay, so that is CIDR. So that's so that really does not make you have the need so much of doing so much subnetting and so on. Like I said also just a while ago, a lot of these details are left to a more advanced course. And in this course, we are going to deal with most of these at the conceptual level. Okay, there's one more question that I see, which is about firewalls. Why are firewalls required? And nowadays, routers have firewalls. Is that good or not? So firewalls, now maybe 15 years ago, it was a new technology, or a new way. More than 15 years ago, actually, more than 20 years ago. So now it's a fairly routine thing that we do. So the idea behind the firewall is to ensure that nobody whom you don't want gets access to your network, while those who you want to allow to go out, you want to be able to allow. So the simplest way of configuring a firewall is what is called the default deny versus the default allow protocol. Okay. So what that means is, if anybody is trying to come into your network, so it's like if somebody is going to come into your home, by default, you are going to deny that person from entry unless they are able to prove some authentication, unless they are able to establish that they are legitimate person in your network, right? And similarly, for going out of the network, so which is like going out from your home to the outside, the default is going to be allow, right? Unless you want to explicitly deny somebody for some reason. So that's the simplest way of configuring a firewall. And usually what happens is that the default allow for incoming requests are usually the web server and maybe the SSH server. Whereas for the outgoing, often the proxy server will turn off some of the sites which consume a lot of bandwidth, for example, and it can restrict the sites that the people inside the network also access. So routers come with firewalls nowadays. So earlier, firewalls used to be separate servers themselves, which were sitting between the router and your own systems. But now you have the router itself can be configured to be a firewall. In fact, you can even configure a firewall on your own laptop, which will ensure that those, even when you are on Wi-Fi, there's no unauthorized access to anything on your laptop. So that was about firewalls. So we are coming up at the 45-minute mark, and I don't see too many people live right now. So what I'll do is we'll wait for a few moments to see if there are any more questions. And then we can close the session. So, sir, just wanted to know what kind of questions may arise based on packet tracer. Okay, if I tell you that, then I'm telling you the answer also, right? So, there won't be any question that you have not already worked with in the activities that were given to you. Okay, that much you can be sure of. If you have done all the activities, then you will be able to answer the questions. So there won't be any new type of surprise or more complex type of questions in the exam. Okay. Okay, so one last thing about while we wait to see if there are any more questions. Since Vishwas and Nisumba are here, we will let them speak a minute about their own topics, not about the course. So you can take a minute to say what is your PhD, what you're doing PhD on.
Okay, so I'll start. Hello, I am Vishwas. I am a PhD student in Educational Technology Department in IIT Bombay. My research area is socially shared regulation and the metacognition happening in that socially shared regulation thing. So it comes basically under collaborative learning domain. Usually we refer it as CSCL, which is computer supported collaborative learning. There are multiple methods in that, different functions or focus points are there of learning. So the metacognition is one of the focus point, and I'm trying to understand the shared metacognition or the shared aspect of that phenomenon happening.
Okay.
Hello everyone, I'm Nisumba Sudhani, second year research scholar in interdisciplinary program in IIT Bombay Education Technology. So my research area is not yet fixed. We are just working around it. I have started with connected learning and I'm moving towards knowledge building. Knowledge building comes from, or knowledge building can be seen where in a platform a group of members work together. It is not about individual knowledge, but more about the collective knowledge a group shares. So this is the preliminary part which I've been working on.
Okay. Thanks, Vishwas and Nisumba, for that introduction to your work. So the point that you would have guessed is that both of them are from the education technology stream, where most of our research is about how to improve learning for students, how to make sure that the learning is more meaningful, more connected, more easy to apply, and so on. Okay, so with that, I think we have waited for long enough to see if there are any more questions. Since there are no more questions, I think we can sign off now. Yeah, so I'm going to close the session in another 30 seconds.
Can you discuss about metacognition networking briefly?
Okay, so there's a question which says, kindly discuss about metacognition in networking briefly. Okay, so metacognition is it. So the idea is cognition is learning, what you learn. So networking, when you learn networking, that is cognition. So for example, when you have learned how OSPF work, Okay, so that comes in the realm of cognition. But when you say metacognition is about learning about what you know, right? So you say that, okay, I know about routing protocols, right? And that's the level of metacognition. And then you say that, okay, there is OSPF which works in a certain way, there is RIP which works in a different way, and now you use your metacognitive abilities to identify, for example, what is the underlying principle which governs routing in general. Okay, so usually metacognition is something which we do not automatically, but
Subconscious.
not even subconsciously,
Yeah.
right? I mean, it is not automatic, it is not subconscious, but it kind of
Indirectly.
indirectly. We do indirectly, but what we in the research that happens at education technology is that we try to make it more explicit. So the moment you make it more explicit, it makes it easier for you to apply it elsewhere. To give you another example, so if you take this troubleshooting example, so the idea here again is that Kavya spoke about those four phases: problem space representation, hypothesis generation, testing, and result interpretation. But now these four phases, you can learn them in networking. That will be at the cognition level, where you learn about which router to go into, what to do with the what settings to change, and so on and so forth. But then what you can also do is you can realize that these are the four stages of troubleshooting are applicable pretty much everywhere. Like, for example, let's say you are there's no power supply, or the Wi-Fi is not working, or something like that. Again, it's the same thing about understanding, or maybe even if you take your own car, it's pretty much the same thing where you make a hypothesis, you test the hypothesis, and then you see whether you need to make a new hypothesis or not. So all these activities that you do using knowledge at an abstract level, roughly you can say that that's metacognition. So thank you for this question. Actually, it made me also think about, okay, what is metacognition in networking? Okay, so with that, let me conclude this session. Thanks everyone for joining, and really appreciate. Okay, so there's one more question about what is your idea behind any improvement will happen in education through metacognition.
Yes. So basically making learners aware about their learning process is important phase. If you see the literature for regulated learning, like self-regulated learning or co-regulated learning, so in that metacognition plays very important role. If you see different models by different researchers, educational researcher or educational psychologist about regulation, then metacognition phases of metacognitions like planning, monitoring, or evaluation, or just making reflections, or just gauging the understanding. These process hold very important place in the process of learning. So definitely it will improve the scenario of education through metacognition.
Okay, thanks Vishwas for that response. Okay, so I've been given a heads up that we have to wrap up in a few minutes. So I'll just still wait for 30 seconds to see if anybody. So I think if there are any more questions about networking or the Demystifying Networking course, we'll wait a few seconds for that. Okay, so there are no further questions, it looks like. So thank you everyone for joining us. It's been interesting to not only revisit the Timbuktu video, but also to talk about metacognition in networking. So we've enjoyed ourselves. We hope you also had a decent time. And with that, I'll close this stream. Okay, done.